All right, here we go. Section 3.10. It's all about rewriting formulas, and what that means is just we're going to be solving for variables within formulas today. All right, but before we get going with that, let's take a second here to write a linear function. I remember a linear function. You can write it in the form of y equals mx plus b. That's a linear function that we're looking for. Okay, find our rate of change, find our slope. All right, thinking about how much, remember it's our change in y over our change in x. I can call this x and this y. Take a second, try part A, and I'll walk through it. All right, well, our rate of change, I got my y or Fahrenheit is increasing by 9, and Celsius or my x is increasing by 5. So that tells me that my slope, change in y, which is 9, over change in x, which is 5. I write my equation, y equals 9 over 5x plus our y-intercept. Remember our y-intercept in this problem, or our y-intercept in this problem should be 32. Why is it 32? Because x is 0 at that point. So a linear function, you could have also said this, Fahrenheit equals 9 over 5 Celsius plus 32. All right, we may actually need to use this, the second one. I know when we talked about this, writing linear functions from word problems, I said just write it in y equals mx plus b form. For the sake of just this problem, I'm going to use the second one, okay, because it's going to ask us to do a lot with it. You'll see why in a minute. So it says use the function from part A to calculate the Fahrenheit temperature that corresponds to a Celsius temperature of 95. All right, so again, like I said, I'm going to use, excuse me, I'm going to use this. Now it says Celsius is 95, so I'm going to plug that in for C. There, take a second, try that. I'm just going to show you the setup real quick. Whoops. F equals 9 over 5 times 95 plus 32. And I got 203 degrees. Holy buckets, is that a hot day? The function from part A to calculate the temperature that corresponds to a Fahrenheit temperature. So F equals 9 over 5 C plus 32. Well, I'm looking for the Fahrenheit temperature, which means if it's Fahrenheit, I'm going to input 95 in for F this time and then work backwards to solve for C. So I have 95 equals 9 over 5 C plus 32. Subtract 32. 63 equals 9 over 5 C. Now you can do this two ways, all right? A lot of us like to do it using cross multiplication. So I could rewrite this as 63 equals 9C over 5. Then put this over 1. I could have also just multiplied the 5 and cleared that out first. But here, which is what we're gonna end up doing anyway. Excuse me. I'm gonna do 63 times 5, even if I do this cross multiplication, to get 315. Then divide that by 9. And C should equal 35 degrees. Okay. So let's keep going. Part D says, if you want to convert several more Fahrenheit temperatures to Celsius temperatures, what operation should you perform on the Fahrenheit temperature? So we basically look at your working part. So you consider the fact that dividing by a fraction is multiplying by its reciprocal. So yeah, let's talk about this. So what was the first thing that I did when I set this up? I subtracted the 32. Okay, what your book is saying that I have 9 over 5C. I could divide by 9 over 5, but really what I'm doing is multiplying both sides by 5 over 9. That's another way of writing, of solving this part. I know that we're more comfortable doing this, okay? Or I have a general feeling that. So what I want to do, I'm going to show you the way the book has it written. They say subtract 32 first. which is what we did. And then they want you to multiply both sides by 5/9. And really, this is a lot quicker. This is a lot faster than what we did. A lot faster. But some of us have, some people have trouble with this whole multiplying by the reciprocal. So what I want to do, so it says use this list of operations to write a function that gives Celsius temperature in terms of Fahrenheit. So Celsius is going to equal Fahrenheit minus 32, which was that first step here. And then that is being multiplied by 5/9. Confirm your formula that works by checking your answer to part C. So I want us to plug that 95 back into Fahrenheit and see if it works. See if we get the same answer. So let's do that work here. C equals 5/9, and then that's 95 minus 32. All right, take a second, try that. I end up getting 35, which is the same thing. All right, so what are we talking about today? When would you need to solve the formula for a different variable, and how does this process for solving for a variable compared to solving an equation for x? We're going to skip the problem that's right below there that talks about the Pythagorean theorem. I want to talk about formula P equals 2L plus 2W gives us the perimeter of a rectangle based on its length and its width. Okay, so this is talking about perimeter. Perimeter of a rectangle. You think about a rectangle. All right, W W L L 2L plus 2W. Remember, perimeter is a distance all the way around a shape. Solve this for L. So what this is doing here, the work that they're showing, all right, they're showing the process for solving for this red variable here. Okay, what do I need to do? I need to isolate this term. I need to isolate the L term. So I subtract that 2W and then divide everything by 2. Now, they're showing this other process down here. The formula can be written in a new form. Okay, we can also split it. All right, what does that mean, split it? Because I have a single term, I just have 2 in my denominator. It's called a monomial. I have a binomial divided by a monomial, which is 2 terms divided by 1. All right, since I have 2 terms divided by 1 like this, okay, 2 divided by 1, I can split it and say that P over 2 minus 2W over 2, which would simplify to P over 2 minus W. Now, why would we do that? To simplify, so that when I go in, if it says, maybe the problem says, hey, find the perimeter, find the length of this rectangle given the width is this and the perimeter is something else. This right here would be a lot easier than going through and doing that. Okay, it makes our life a lot easier. Just like this process here is easier than going through all of this. Okay. Is it required that you split it like that? That's a good question. I would like to say that you should always write your terms, always write it in its simplest form. All right, always simplify. This is how it works. This is just determine the variable needs to be solved for the unknown. Treat your variable as constants and solve the equation as an unknown. All right. So what they're basically saying is you're trying to solve an equation. All right. So you're using the same principles as if you were to solve something like this. I don't know, 2x plus 4 equals 12. Okay, I'm using the same exact rules, using my same exact principles as solving that type of. All right. So this first one, 3a, asks us to solve for t. Well, the only thing that's attached to that t is r. So if I were to imagine this says d equals 2t, I do to isolate the t. I would divide both sides by 2. Same type of idea here. I'm going to divide both sides by r. These r's cancel out, and t is equal to d r. Now, d equals r times t, that's distance equals rate times time. I don't know, that's a little that, okay? That you remember that, but I just wanted to say it. This question's a little bit different. It says solve for R. All right, R you'll see is right there. Okay, so this one, like I said, is a little bit different because R is attached to two variables, but that's okay. We're still going to treat it the same. So what I want to do still is I still want to isolate this term with R. So I'm going to subtract P from both sides to get A minus P equals PRT. Again, we're trying to isolate the term with the variable that we want to solve for. So again, I want to solve for R. So I'm going to get rid of everything that's attached to it, the P and the T. So I'm going to divide both sides by PT. So I'll get, these all will cancel out, and I'll get R equals A minus P over PT. And that's it. R is by itself. We did our job. Let's try part C. Part C is a little bit different because R is being squared here. Okay, but we just spent, some time solving for squared terms, solving nonlinear equations. All right, so we want to use those. And there's a reason we did that first, right, to just give ourselves a refresher before we started solving for individual variables. All right, so I want to solve for R, which means I have to get R by itself. So I want to isolate this R squared term. So I'm going to divide the 4 pi out. So I have S over 4 pi equals R squared. Now, remember, in our last section, to get rid of a squared term, I have to use the inverse operation, which means I have to undo a squared. What's the opposite of a squared? It's I can hear you now, a square root. So I want to square root both sides. The square and the squared will cancel out. And I'll square root that. Now, technically, you're not allowed to take or have a square root in a denominator. I would have to rationalize, but I'm not concerned about that right now. I'm more concerned about our ability to solve for the variable. I would just leave it like that. That's the best way to do it. Solving a linear equation for y can help you identify important information about its graph as shown in the next example. So now we're going to switch gears a little bit and we're going to apply this to a linear equation. We're going to apply this to a graph pretty much, okay? We're trying to look at graphs or look at the equation with x and y and solve that for y. Now we've done this before. We started doing this before we took our quiz. Okay, so it says find the slope and the y-intercept of the graph of the following equation. Well, to do that, I need to get this equation in y equals mx plus b form, as it says right here. It'll be easier to identify the slope and the y-intercept if the equation is in slope-intercept form. To get this, we need to solve for y. All right, so to solve for y, I want to isolate my y term. The y term is negative 3y. I'm going to move this 4x to the other side. So I have negative 3y equals negative 4x plus 12. The one thing stopping me from isolating that y is the negative 3. So I'm going to divide every single term by negative 3. Now, this is one of those cases where if I go back to here, yep, here it is. Oh, buckets. There. Where is it? There it is. Oh, man, we're jumping all around. All right. There it is. Okay, sorry. So this, man, that's not it either. There it is. There it is. So this is kind of an instance where I could divide everything. I divided everything by 2 and then I split it. Okay. Same kind of idea here. All right. I could divide everything by negative 3 and split it, or I could just go through and divide each term by negative 3. I think it's easier to just divide each term by negative 3. Why? Because I'll realize that I have to do 12 divided by negative 3, and I'll realize that, hey, negative 4 divided by negative 3 becomes positive 4 over 3. Okay. If you look here, the slope is 4/3. The y-intercept is negative 4. which should be written as 0, comma, -4. We're going to pause there. Let me know. It may have been a little laggy today, so if it was, just let me know when you come back to class, and if you missed anything, I'll re-explain that to you. All right?